Hello and welcome to another of our videos on implicit differentiation, this time with a toolkit for things that will be very useful for you to be able to do a good set of skills for exam questions. As it says, these are the standard skills expected of the competent implicit differentiationalist. So, for number 1, we've been asked to differentiate 3x squared plus 2xy plus y squared equals 72. And although it doesn't say it, we're going to differentiate it with respect to x. 2xy is a product of x and y, so we're going to be using the product rule. Y squared is a function of y, so we're going to be using the chain rule. Both of those rules demonstrated in the previous video on the process of implicit differentiation. So when we differentiate 3x squared with respect to x, we get 6x. When we differentiate 2xy, because it's a product, we get two terms, 2y plus 2x dy by dx. When we differentiate y squared with respect to x, we get 2y dy by dx, and when we differentiate 72 with respect to x, we get 0. So overall, we get 6x plus 2y plus 2x dy by dx plus 2y dy by dx is equal to 0. And every term, when we differentiate it, has been put in the place where the original term was in the equation, and we're not putting it equal to dy by dx. However, in part 2, we have been asked to make dy by dx the subject of our answer. So in order to do that, we can see from the original differential there are two terms with dy by dx. So we're going to move everything else over to the right. We're going to factorize out the dy by dx and then divide. And if we do that, we'll end up with dy by dx is equal to negative 6x take away 2y over 2x plus 2y. And then if we divide each of those bits by 2, we get negative 3x take away y over x plus y. Okay, so for part 3, we've been asked to find the coordinates of the point on the curve for which y equals 6 and x is positive, i.e. greater than 0. We've got the curve at the top, 3x squared plus 2xy plus y squared equals 72. The first thing we're going to do is to substitute y equals 6 into that, which gives us 3x squared plus 12x plus 36 equals 72. It's a quadratic equation. We can take away 72, divide by 3, factorize it, and in theory we would get two answers, one of which would be negative 6 and one of which would be 2. But since we know that x has to be positive, the answer we want is x equals 2, and we already know that y equals 6. So that gives us the coordinates 2, 6. And then for part 4, find the gradient at this point. Well, we know that x is 2 and y is 6, so we can go down to our formula for dy by dx. Minus 3x take away y over x plus y, substitute in x as 2 and y is 6, and that gives us an answer of minus 3 over 2. So the next skill required of a competent implicit differentiationalist is to find the equation of the tangent or normal at a point. So we've already got a point, 2, 6, and a gradient of minus 3 over 2 for the tangent. So using y minus y1 equals mx minus x1, y1 is 6, x1 is 2, our gradient m is minus 3 over 2. Substituting those values in and then rearranging it into the form ax plus by equals c, where a, b and c are integers, we get 3x plus 2y equals 18. And we do exactly the same for the normal, except the gradient is going to be 2/3 because we've reciprocated it and changed the sign. And this time they want it in the form ay equals bx plus c, which will give us 3y equals 2x plus 14. So our sixth skill is to find the turning points on the curve. It says that we need to give our answers in third form. So that means that we want dy by dx to equal 0. Now we've got it as a fraction, minus 3x minus y over x plus y equals 0. So on that basis, all that's important is that the numerator equals 0, which tells us that minus 3x minus y equals 0, and hence y equals negative 3x. And then what we can do is we can substitute y in our equation as negative 3x. So the first term is still 3x squared. The next term becomes a minus 6x squared. The third term, if we square minus 3x, we get plus 9x squared equals 72. Simplifying that gives us 6x squared equals 72. So x squared is 12. And that means when we square root 12, x is plus or minus 2 root 3. And because y is negative 3x, y is negative or positive 6 root 3. So pairing them up properly, we have x as 2 root 3 with y as a negative 6 root 3, and x as negative 2 root 3 with y as positive 6 root 3. And finally, a new skill. We've been asked to find the points on the curve for which the gradient is infinite, and I've put in brackets, i.e. parallel to the y-axis. So we're used to doing turning points where the gradient is 0 or some other slope, but it's very rare that we'd be expected to work out when the gradient is infinite. Okay. Now we can't put the expression for dy by dx equal to infinity. However, we can state that the denominator is 0. Okay. So if x plus y equals 0, that means that y is negative x. And just like in skill 6, we can substitute into the original equation. So this time we get 3x squared minus 2x squared plus x squared equals 72, from which 2x squared equals 72, x squared is 36, and x is plus or minus 6. And again, y is negative compared with x. So if x is plus or minus 6, then y is minus or plus 6, giving us 6 minus 6. And minus 6, 6 as the 2 points on the curve for which the gradient is infinite.